So question 16. There are only red counters, blue counters and purple counters in a bag. The ratio of red to blue is 3. Right, so I'm going to write this. Again, I want to own something. Red to blue is 3 to 17. Sam takes out a random counter of the bag. The probability that it's purple is 0.2. Now that's really interesting. Purple being 0.2 means that 1 out of 5 is purple, so it's 1 to 4 ratio. So if I wanted to put a purple one here, what value would be there? Well, that would be effectively 4 to 1. So R plus B to P is effectively 4 to 1. There are 4 times as many of this than there are to this. So that's really, really interesting. So what I can then say is, okay, add that together, that makes 20. So it's 20 to something. And to go from 4 to 20, I'm going to times by 5. So I'm going to times that by 5 to keep it all in line. So therefore, I know that there are 5 purples to 17 blue to 3 red. So now I've got all my parts. It then says, what's the probability that it takes a red out? Well, we know there are 3 out of 20, 25. There we go. So the probability is 3 over 25, or if you wanted it in decimal point, that would be 0.12. But again, a really nice question. You might want to just slow down on that one, look what I've done, and redigest what I've done there, and take time on it. Right, question 17. Okay, looks messy, but often I find there are tricks here that you can apply. So simplify fully. Let's look at this bottom guy. I can see a 2 and an x. So what I'm going to first of all do here is take out a 2 and an x. And that means I'm left with an x inside, because that gets 2x squared, minus, and then I need a 3 there. And what's really powerful about that is that if I know that's the case, and I know I'm going to have to simplify, one of these is going to be a factor up there. So let's just take that out here. And I'm going to make a big assumption here. I'm going to assume that x minus 3 is that common factor. So I'm going to guess that. I know x goes there. Minus 3 times what makes minus 3? Well, that must be plus 1. Now, let's just see if this works. Minus 3x, and that's plus x. So, oh, that's supposed to be a 3 there. Let's just see what's happened here. Oopsie daisy. Right, let's unwind on that one. Okay, let's just unwind on that. Sorry about that, guys. So we're going to go out like this and say, I know 1 is that. Now for this to work, that must be 3x there. Yeah, now we go. Now we're rocking. So that's going to be 3x, make 3x squared. And then minus 3 times plus 1. Now, there we go. That fits much better. That feels a lot better. That's minus 9. And this idea here to check is really important, because then you realize what mistakes you make. So checking is really, really powerful. So I'm going to keep this video here simply to show you we all make mistakes, but checking it is power. So now that plus that is plus x, and that means you get minus 8, which is we want there. So now put this back up the top there. And even though this might make me look stupid because you should get it right, it's great because we all make mistakes. And this is how I recovered from it. Now here I can cancel out there. So I'm left with 3x plus 1 all over 2x. And that's question 17. Right, let's see, question 18. Okay, question 18. Here's a graph of y equals sine x between the regions of minus 180 and 180. You don't really have to worry what sine x is. We've done this before, but there's your function. And then it says, look, we're on the escalator here because we're on the outside and we're dropping down 2. So we're literally taking this graph and dropping it 2. So everything goes 2. That goes down to 2 there. That 180 goes there. That 180 goes there. So it drops down.